Okay, hello. Okay. Sorry for a bit delay, a bit of technical issues here. Yeah, so it's my second attempt at streaming, and yeah, somehow I'm more nervous than last time. Cool. I can see. Okay, I'm live. 10 minutes. Can somebody, like, can you hear me? Big question. Because yeah, always difficult to know what's happening here. Second attempt at streaming. And okay, that's my own stream. Cool. Right, maybe quick tweet that we are live, and we're gonna start. Where is that profile? Okay, there we go. No, this one. Quote tweet. And we are live. Cool. Okay. Yep. Okay. Mike, Damien. Awesome. Right. So actually, if you go to this thumbnail for a second, what I wanted to talk about is a bit of continuation of the topics we covered last time, but moving from 2D to 3D. So I'm gonna base my work on, yeah, I was talking about this tweet. I'm gonna base my work on one of the examples that's included in the distribution of nodes. So if you download and, oh, that's docs, whoopsie daisy, this guy. So if you create a new example, blah, let's move the microphone a bit. It uses Specs Renderer, which is a 3D library, not so much different from 3JS that we develop at our studio variable. It allows you to use WebGL to create 3D shapes and use materials and lights and all the stuff that you might expect. But we don't need all of that. You can go through this in your own time. What we're gonna do is, yeah, this thing. Okay, it's a mess today. Okay, so just to quickly cover what's included here. So you have WebGL context, then you have a debug node that logs some WebGL error messages if they happen to occur, and we have renderer, which loads the Specs Renderer library. And most of the nodes you see here, they are built in this example that didn't open, or did open? Maybe I closed it. Anyway, yeah, I closed it already. They are built in this example, so you can just like copy paste them. And there will be some modifications that I made that, yeah, might be included in the next update of examples. And we have a camera component, an orbiter, which allows me to drag the scene with a mouse, zoom in, zoom out. And the difference compared to the example is that I have added projection mode. So, okay, I'll save it if it doesn't, if it breaks. So with perspective, yeah, it's broken. Great. Let's stick to orthographic. So orthographic projection, yeah, persists the kind of lengths and widths and heights and kind of creates this isometric view, which will be useful for something I'll try in a moment. We have a post-processing. Let's don't touch that for a moment. And then we have a skybox that allows me to generate the sky to kind of lit the scene a bit. And I have this like a color generator that can create a square of any color. And if I plug it into a texture, then I can replace the skybox with a solid color while maintaining the lighting. So that's pretty handy. So that's this one. And then I have two lights, two directional lights. And if you attach this light helper component, and if we rotate our entity. I'll explain what the entity is in a second. It changes the direction of the shadow. So entity is kind of a game object or object 3D, or kind of like an instance of something in 3D space, and then we attach different components to it. So for example, we attach this directional light component or this helper that draws the lines. So I'll disconnect this, and we have another directional light component connected to another entity. So if I plug this in here, then it's connected via trigger ports all the way to renderer. So the renderer knows to use it in the given frame to render the view. And outside of that, we have two more components. So we have this one entity here, which has a big material component with all the like physically based rendering properties. And then we have, whoa, let me just check something. Okay, and then we have geometric component that contains a cube, and that cube is scale 5015 to create this kind of flat floor. And then we have another messy last minute work setup where we have material. So let's do something like, I can change color to red, or I can create a sphere, which is also included in the example, and replace it, and then I'll have a sphere here. But today is gonna be all about cubes, so let's stick to cubes. Cool. So in order to kind of explain what I'll try to do today, we'll try to do a couple of things. So I collected number of references from 3D graphics, generative art, and color theory. I have work by Kjetil Golit, big fan. We have projects by Frederick, for example, and Andrew James, and things like that. And they're all kind of based on, another James Owen. They're all based on cubes and different layouts, and some of those layouts can be recreated procedurally with code. And the cool thing about it is that having lots of uniform shapes kind of screams for some interesting color palette. And what I hope to do is both experiment with a number of layouts, but then also try to create colors, or maybe first use some existing palettes and then create some color palettes using color theory, like this one here, to assign some interesting colors to them. Right, okay, so back to, again, I have pretty pictures. If you go back to notes, yeah, and also I will try to keep track of time. Hi, oh, cool. Oh yeah, I need to move the camera, I can't see me. Okay, something like this, yeah. Great. Okay. Right. So because we need a lot of cubes, so let's put it here, and can click alt click and create a comment. So I'll call it floor. Okay, you can increase the font size here, kind of know what's happening. And then we have another object here, and that's gonna be our mesh. Okay. So in order to create lots of cubes, I can just, like, you know, copy paste it and then move it a bit, and then copy paste it and move it a bit. That's good. That's gonna get pretty tedious quite fast, and there's no easy way to control that with code. So instead of that, all kind of modern 3D graphics libraries support something called instancing, which means I can use one object and then provide number of positions, offsets, or translations, and this object will be copied to all those positions. So this will require us to add a bit of code, and well, let's try to do it, because that's gonna be base for our exercise today. Okay, so I have a cube, and I'll create a node, custom nodes, and I have two ports, one port const geom in geom. It's gonna be our geometry, and const geom out instance geom. Okay. And now whenever this input geometry changes on change, we're gonna get a callback instance of that geometry, and now we need to check if, for example, if okay, let's recompile it with shift enter, and now I have this input and output ports, and I'll call it instanced geom. And now for example, like if I connect something, that geometry will come here, but if I disconnect it, then I'll get a null here, empty value. So I always need to check if there is something there. If not, just exit, return early. Okay. So in order to like add instances to it, we'll copy all the properties of the old geometry. That includes like positions, nodes, positions, UVs, normals, like faces or cells, and then we add new property called offsets. And then this thing has an array of positions in this data property, and also PEX render requires this parameter called divisor, which suggests says how many meshes per point there will be. So there will be like one mesh per vertex, more or less. Okay, and now I can do something like for I equals 0, I divided by, I don't know, 50. I'll create a loop and I'll create 50 cubes. So say new geom offsets push, and we need the position here. Const position, and I'll say math random times 5 and 3 times 5. Okay, and at the end I also need to say new geom instances, so that will how many of these cubes there is, and that's new geom offsets data length. Okay, oh yeah, okay, new geom offsets data. Okay, so now in theory, if I replace this geometry with this instance geometry, will I get something or not? That's the question of live coding. New geom offsets divisor. Okay, I need to set it to the output port. Geom out, set value, new geom, boom. Okay, so now I have 50 cubes, and the cool thing is that I can make it more evenly spread. So if I do 2.5, okay, this will create from -2.5 to 2.5, and if I change something here, like change size, like changing size of this mesh creates new mesh, and it goes down the wire, which creates new layout. And in order to like prevent that layout to be always different, you can import the package called const random, called PEX random. PEX random, and now this PEX random has a method called seed that will start random number generation from a given point, which means as long as I have my seed is called 0, as long as I reuse the same seed, I will create the same positions, and then I can just say const pos is random vec3 5. So this will create a vector within radius of 5 units. So now if I resize this, the generated random numbers are always the same. And as I modify those meshes, yeah, they create the same positions, just with different scales. And the cool thing is that I can create sphere, and if I replace this with sphere, I'll have spheres. So now, if I make parameter out of that, let's say const count in count, say 50 and precision 0. So precision 0 makes it an integer, so I can't enter 50.5 because it doesn't make sense. And then I use this count value here, and I need to make this a function, const update, and then whenever geometry change we call update, and whenever count count is called, it's also call update. So now if I increase the number of point, or I can do like 150 or 500, this changes, and I can then add another parameter called seed, do the same thing here, seed in, put it here, yeah, okay, seed, yeah. And now if I modify this random seed, I get different results. Now let's stick to cube, no more spheres today, and change to 1 1 1. Okay, so one cool thing we can do to make it look a bit better, we can go to our post-processing component and add this thing called screen space embed occlusion, which in theory should work. Let's see. Radius intensity. Is it working or not working? Yeah, okay, let's remove this. Let's remove this. Oh, and skybox higher. Live streaming. Intensity. Okay, this is too intense, and the radius should be. Okay. Yeah, okay. I don't think that's gonna work with orthographic camera for some reason. Post-processing, SSAO, yeah. Okay, great. So this is working here. Too strong. Yeah, okay. Sharpness. Intensity. Yeah. Okay. Something like that. And doesn't work with auto camera. Back to fix. Okay, you can stick with this one for a second. So that's one thing. Increase this radius and decrease intensity. Yeah, and reconnect our directional lights. Okay. And maybe this is too bright. Yeah, anyway, something like that. Looks good. Cool. So we have our instances. And now another thing I wanted to show is that we're gonna try something different. So actually, I'm not gonna code it live because there's no point. So earlier I prepared this node called Blender point instance, and what it does is has two parameters, geometry and object. And what it will do, it will copy the shape of the object, but it will take the offsets. Will take the offsets from the positions of another geometry. So what this allows me to do is, if I take a cube and plug it into the object, and I create new cube, or copy paste the old one, and plug it into the geometry. What this will happen, let's see if it works. Okay, so if I make my cube 3 units long and 3, yeah, okay. Let's do this, and I'll explain what's happening. 1. So I'll make my object cube very small. Okay, and this cube is 3 by 3 by 3 and divided into 3 sections. So if I divide this big object cube into 10 sections, it will create per vertex a new instance of that cube. And that's quite awesome, because if I take torus, it should in theory, okay, yeah, so it can create at all the points and vertices where the torus has points, and there's quite many of them. So if I do this and increase number of segments or rings, yeah, you can quite easily duplicate something here. And now again you can start playing with it, because yeah, it's just cool. It's quite cool. So again, let's keep this. And what I really want to do, so this is just like one of the ways to create this instance positions. And what I'm gonna try to do is kind of play with different algorithms to create this geometry, and also assign different colors to them. Okay, so I'll create new node called well, it's gonna be custom node, but it's gonna be algorithm 01, and I'll start with cubes. So create cube, primitive cube. So I'll start with basic, like, okay, so this algorithm will create a geometric shape, and then on each of the points of that shape we'll put this little cube there, and then we can add like things like scales and colors and so on. Because right now it's a torus. Okay, so do something like this: const geom out, node out geom. Okay, so this will be our output geometry. And now I'll do something like function update, and call it update. Okay, so this is function that will be called immediately after this node is recompiled. And I'll say something like const g is create cube, yeah, 5 5 5, or yeah, 5 5 5 5 5 5. Okay, so it's like a width, height, and depth is 5, and then there is like a 5 segments on the width, height, and depth axis. And if I set it to geom out, set value g. Now if I plug this here, okay, we have a cube. And now the reason why I wanted to use orthographic camera is that I want to create multiple versions of this thing. So I'll create 3 versions of this thing by copying all the positions 3 times, and that will allow me to kind of see 3 versions of the same algorithm every time I modify something. So let's call this thing cube and create our geometry as an empty object. And now I have for let I 0, I'll make loop of 3, yeah, loop for 3 shapes. And I'll have my center. Okay, let's like this, const centers. So my shapes will be at position 0 0 0, and then 5 0 5, and I think the last one is -5 0 -5. So now what I'm gonna do is copy 3 times all the positions from cube to my geometry with that offset. So this should create like 3 cubes out of points. So I can, it's very inefficient, but just to make things easy, I can do cube positions for each. And I have a position, and I'll say G positions push, and I need some math library for adding vectors, and the one I'm usually using is called PexMath and has a vec3 class there. And now I can do const new position as vec3 add vec3 copy position and center. So this is like creates duplicate of the position from my original cube and add centers I. So we'll add one of these offsets here. And if I push this new position, okay, so it worked. So I have 3 cubes. And if I do maybe move it further apart, 6, 6, 6, 6. Okay. You know what? I'm gonna disable for now the screen space ambient occlusion and switch to ortho camera, because then we can have it nicely like this. And then I can maybe shrink them a bit so they're not so big. Okay, so let's say 3. Yeah, okay. So I have 3 cubes. And if I move it up, okay. Now I also need 3 floors, and let's say we do it the lazy way. So I'll copy the floors 3 times. Copy the floors 3 times and set it to 6, 6, and -6, -6, so I can see some shadows. Okay, and now it's gonna start getting funny, because I have positions and I can also add scales and colors. Okay, and now, so for each cube I create new scale, just random. Okay, I need my random package. Random require x random. So create scale which is from like half the size to double the size, and I can say G scales push, and the scale is vector 3. So now my geometry has scales also. So if I recompile this and add those scales here, scales and scales, now all those cubes, they have random sizes. So in order to clearly know what's happening, let's resize this cube to unit size. Okay, because then I have full control over this, and then we can have size from like 0, 1 to 0, 6, like this. That's pretty cool. And now let's create random colors. G positions, G colors, push color. And now my color will be completely random. Color, math random, math random, math random, and alpha also random. Okay. Just checking something. Okay, we now have alpha testing. So this is algorithm 1, and now we add support for colors here. Same way as scales. Colors. Boom. Wow, what's wrong? Colors, geometric colors. 1, 2, 3, 4. Yeah, okay. So it looks like okay. So we have alpha testing. So random color with transparency. I haven't enabled transparency, but you can see that I have different transparency here. So if I have alpha test above 1, that will create a threshold below which the geometry is not rendered. So if I reduce this to 0 and disable blending, then all my cubes will happen. And now they look very Shrek-like. And that's because the cube itself has a green color, so the instance color will get multiplied by the base color. So now if I change it to white, yeah, then I'll see like only the original colors that are kind of randomized here. And let's go format this code a bit, format code, and now we can play with it. For example, if I randomize only red and put 0 at red, grid, blue, then I have just, yeah, every time I press shift enter now I do recompile something. Okay, so amazing, we create first algorithm, just random cubes. So if you go to references, I mean, I wanted to keep it to half an hour today, just not to go crazy, and either speed up and just show quickly things or continue later. But one of the cool things I wanted to do is these guys, which are made out of Lego, and I think it's quite fun to do because we can create multiple instances of the cubes and then use Berlin noise to kind of carve out the holes in them to create those kind of towers. So if I go back to nodes, and I'm gonna save it and copy paste this algorithm, call it algorithm 2, reconnect it here, maybe create, I don't know, everything in white, so it looks like Lego. Okay, have these guys, oops, okay, zoom out a bit, and now my cube will be quite higher, so we'll say 12 in 12 subdivisions. Whoops. Okay. And maybe a bit more narrow, and we need definitely more instances on the sides. Okay. And then because this thing is 12 units tall, then if I add 6 here, I should more or less center this thing. And if I go here, make sure it's on the ground. Okay, then I have my towers here. Okay, I can't pan with this camera. Great. Okay, can keep it like that. And now this cube is too big, so those cubes should be also smaller. Okay, oh, that's too small. Like, let's create the same value for now. 5. Okay. 12. Okay, I need more units here. 24. Okay. So now this is full. So what I can do, I mean, I think I was showing Berlin noise last time. So Berlin noise. Yeah, looks like that kind of cloud. So if we sample Berlin noise based on the position of the cube and then maybe shrink it, should create quite cool effect. So I'll say const noise is random noise 3, and then new position 0, new position 1, and new position 2, and that will create number from -1 to 1. And I can say scale is scale. The scale is 0.2 plus 0.2 times noise. Okay, okay, and that kind of works, but I think the frequency of that noise is too high. So I need to create a new variable called frequency. Now in freq, yeah. And when the changes call update. Frequency is this, and if I multiply each of those, okay, let's read it first. Freq, and if I multiply xyz by this, then we can change the frequency at which this noise is changing. Yeah, so if I do 0.2, getting into the Hahadi territory, and I think we need to increase the scale here. Wow, okay, this is too much. 35, 2, yeah, this looks quite cool. And now if I go back to perspective camera, okay, yeah, okay, I can keep perspective camera, and then turn on SSAO again. Yeah, you can see like the shadowing there. Cool. Okay, maybe bigger. Cool. Yeah, so we have these buildings and we can play with frequency again. Yeah, we have the shapes that get hollowed. Oh, looks better from this side. It's actually quite bad resolution. If I go here, context, if I bump the resolution, yeah, that looks better. Okay, so that's one thing. And so we have 3 versions of the same thing, and then let's play with colors. I have 1, 2, create next one. So I showed you how to create random colors, and if you go back to where's the color? Okay, so color is here, right? So we can have random color, say math random again. Random. Okay, so this creates random colors. But it would be nice to have some more useful color kind of what do you call it? Color model, like HSL, for example, so hue, saturation, lightness. So luckily the PEX color module const require PEX color has a method called from HSL that takes hue, saturation, lightness and returns a color for me. So I can take this, comment it out and say from HSL, so hue it's from 0 to 1, so random float, and saturation let's say 1, and lightness 0.5 I think. So now if I change saturation, it gets more and more pale, and lightness goes from white to black. So 0.5 is the kind of full saturation here. So now what we can do is, because we have 3 of those buildings, we can create like get our base hue, random float. So this is our base. That will be the same for the whole building, and like this. and kind of vary it's slightly per building, right? So I have like const cube hue is hue plus random float minus 0, 1 to 0, 1. And if I use this, now the kind of thematic colors, right? Whereas, okay, this is too saturated. Let's change the saturation a bit. Okay, these are more plausible, more kind of yeah, eye candy. Now, okay, so one notice here, like I'm writing lots of code, right? Like this is all kind of manual, and we came here for nodes, visual programming, and why do we have shader graph or some effects graph or something, or like vertex operation graph like in Houdini. And it's something we're working on, and it all kind of depends on building your own vocabulary. But like I did this point instance node, for example, like I've tried different approaches that kind of simulate Blender or even Houdini, where you have kind of transfer color from a different object or randomize given attribute or have a little formula you can enter and then kind of stack them together, create a mesh, add random color, add scale based on some function or something. It's not something I'm gonna try today, but yeah, it's definitely possible with a bit more work. But what I wanted to do is now that we have this noise function that creates these holes in those buildings, would be like extremely cool if the color was depending on that as well. So now one thing I like to do with noise is I like to multiply it by itself, but where's scale? Okay, so noise is from -1 to 1, and if I do multiply it by 0.5 and add 0.5, so now the noise will be from 0 to 1. Then I can change this. Sure. Okay, and if I multiply it by itself, it should give me more contrast. Okay, maybe that's too much, so let's stick to what it was. But now in theory, instead of having this random hue here, or let's say, let's copy this guy. Sure. 4. Instead of having this random offset view, I can actually use noise plus noise. So if I do it like that, that's crazy too much, because it go from 0 to 1 is 360 degrees on the kind of color wheel, so it will go all the way through the whole kind of rainbow of colors. But if you do a bit, or maybe like that, then you can create those data-driven patterns, right? And because we have hue, saturation, lightness, then we can do something like lightness and base it on Y position. And for that, there's a super cool function in XMath package in the utils submodule called map. That's, you know, probably most commonly used processing function as well, and that allows us to map new position. For example, Y coordinate of the position, that is from 0 to, now we know it's from 0 to 12, and we can remap it from 0 to 1. So now the bottom of the building should be, let's do 0.5. The bottom of the building should be black and the top should be colorful. If I multiply it, yeah, it did work. And if I go all the way to 1, it will, yeah, go to the white color. Right, so yep, so that's that. And wow, it's already almost 1 hour. Okay, so one thing I wanted to try, so this is like procedural color, and there are people with much better color schemes color skills than me, like I'm pronouncing his name wrong, I'm so sorry, Kietil. And he actually created a library called Chromatom. So why don't we try to use this one? Comes with like lots and lots of color palettes. So if I install this, nodes, packages, Chromatom, let's add it, save. Okay, save, reload. Cool. And what's this? Okay, this one. So let's create new algorithm. Shoop and 0.5 and import the library. So const chromo, what is the name? Chromatom. Require Chromatom. Now let's see what's inside. So I require, and then console log it and say view developer tools, and I think that's the library. Okay, so there's a function get all that gives me all the color palettes. Get all 157 color palettes. Great. So each color palette has a background color, name, and a list of colors in hex codes. Okay, so great. So I can say something like const palettes. So this gives me a list of all color palettes, and then for each building I can get a random color palette and say we can do two things. We can do like palettes random int 0 to palettes length. You can do like this, or that's way easier with random element. This just returns random element from an array. So then I have a color palette, and let's get colors from there. So const colors, and those colors are in hex codes, and we need floating point numbers for WebGL. So we import another function from PaxColor called from hex and and map those colors. So for each color in this area we'll call this function, and we should hopefully get console log colors, palette colors. Okay, we should get the list of objects, yeah, of floating points, floating point RGBA colors. So now when time comes to draw a cube, instead of this HSL function, I can say const color is random element from colors, and there we go. Insta poster. Cool. And maybe we can tweak the background a bit now, make it more trendy. Quite like the blue, yeah, metallic gray. Awesome. Well, not this one. Save screenshot. No, I don't have it. Okay. Yeah, I wish I had this save screenshot method here from another project, but I can just take screenshot like this for now. I can go full screen. Get even better resolution. Yeah, and why don't we go a bit crazy here, in a sense that I create those guys, because we almost end of stream, and I definitely need to continue next week with part 2. I'll create new mesh, and what I'm gonna do is I have the same algorithm, but because it's has different seed, it will create different colors. But for this guy, I'll just create everything in white. 1 1 1 1, and then random alpha. So I can filter it by the alpha test property. So there'll be only a few of those. And I can take this cube and make it very thin, but very long. Very long, and make this whole thing a bit wider. This guy like 3 and 3 to create this kind of scaffolding. Now the cool thing is that because it's physically based renderer, I can make this thing look metallic. So I said metallic here, 0.1 here, and if you make it a bit yellow, maybe metallic roughness. Okay, and let's say rounded cube here, and do the same like 0.2, radius 0.1, 0.2, but that's too narrow. 4, 0.4, 2. Yeah, okay. The FPS is suffering, but like not much cool stuff is happening here because we don't have HDR cube map. So if I say HDR texture and load some of the environment maps, like Venice sunset, and go to my skybox and plug it here. Okay, actually I was doing it wrong. It should be here, and this background texture should be in the background texture. So now I have this kind of metallic look. The default looks quite cool, very sculptural. Okay, there you go. NFT precious. Yeah, and I think it's been 1 hour, so yeah, this is super heavy, this rounded corner cube. Let's make it a cube again. Shoop. Barely can render. 0.2, 0.2, and I kind of like it non-metallic. Okay, let's copy this material and do another one. Non-metallic, just pure white. Pure white. Yeah, there we go. Finished project. But now, okay, because it's generative. Yeah, so let's say, oh, actually I want so many more of those things. So I can just copy my algorithm 5. Their algorithm 6, and make a little city out of it. So instead of using those centers, I will create 10 buildings, and my center, instead of coming from here, center will be random float from -10 to 10 and 0, random float from -10 to 10. Oh, and it has to be per building like this. Okay, and where's that? 6, right? So we have this algorithm 06, and we use it here as well. back to color from color palette. Where is that? Broke everything. Okay, there we go. Yay. Oh, why it's wrong? Yeah, okay, because they are random, so they will happen at random positions, so they will not match. Great. So I'll need to hard code a seed here. Random seed 0 or like 10, and same here. Okay, whatever, broke it. Where's my camera? Camera component. Far. Not this guy. Far. 1000. So you can avoid clipping. Okay. We fix that. And then random center scale. Okay, so this is 3. So those buildings were more narrow. So if I changed it to 2, yeah, okay, there we go. Hey! And now they're missing little floors. So if we push one more floor per point here. So there are any questions on the stream, now is the time. I'm gonna do like this: G positions push center, and G scales push. Okay, center 0, 0, center 2, and scales will be 10, 0.1, 10, and G colors push white. Yeah, so they'll create a floor per building. Yep. Ta-da! Finished. Okay, I'm 5 minutes behind. Yeah. I know what we can do. Can go to algo and use our noise and choose the color based on noise. So color is math floor colors times noise. Colors length. Oh. And why it disappeared? I create some invalid color somewhere. Maybe I need to clamp. Math max 0. I think noise can go below 0 sometimes. That's the reason. No. Well. It has different offsets because okay, I know what happened. No. Yeah. Okay, I know what's happening. Because I'm using different amount of random functions, my seeds create different offsets per buildings. So I create the buildings, but whoa, yeah. Okay, now I just call this random element, I ignore it and overwrite it. So now the number of times I called random dot something is the same as my facade. So yeah, okay, there we go. Finished. Woo! Thanks. Yeah, there's a number of things I wanted to cover that we never really reached to. So like different layouts, like subdivisions, and maybe some repetitions and so on, kind of more in space, but also not just using libraries, but different ways of accessing color data. So something I commonly use myself is like, besides using this awesome library from Ketil, I also sometimes use image-based palettes, and I'll like load a PNG like this, for example, and then step through each cell and kind of steal the color from it, or do the same thing from the circle, kind of programmatically. And something I really wanted to try is, if you go here, it's kind of like color theory 101, but like select like generating color palettes based on, like, for example, complementary colors. So if you first color is like orange, the opposite of that would be blue, and then you create a bit of shades for them, so you have kind of two colors there, or like a sequence of increasing hue. So if I have blue, it goes on to pink, and orange kind of towards green and the red, and so on. And try how this would work, because it's always a struggle to choose colors that look nice and are kind of decent. And for example, this still looks gray. To go to my camera, where is it? Exposure, bump exposure a bit, maybe. Yeah, kind of depends what kind of lights are you using, and HDR maps and so on. So if I change the HDR map here, yeah, probably too much, too many directional lights. Bye bye. There we go. Yeah, anyway, cool. Yeah, I'll put that code somewhere this time, I promise. So you can play, or otherwise in the meantime, we have this specs render example that gives you some of those basic cubes. Okay, there's some other examples that I didn't get into, managed to create while preparing for that, and broken state and so on. Okay, cool. See you next time. Cheers. How do I stop?